Hi there. Let's work through this problem that you sent me. I'll make this video for you and send it back, and hopefully can help out. So what I've written in purple here is where I think we've done a good job. So started out with this integral. You took the 9 and put it outside, which is great. Then you use integration by parts to figure out this negative e to the x times the cosine of x, and then plus this integral. And then you did it again to end up with this, the next line. All of this looks fine. And then you did it one more time and you ended up with this term over here on the right that looks similar to this term that we started with. So all of that looks fine. And then I think what you did, for what I've wrote in red here, is incorrect. So I think what you did then was say, well, what I have is, let me recopy here something. So I have integral from 0 to pi 9e to the x times sine of x dx, and I'm copying down what we started with. And then I think you took this term and added it to the other side of the equation. So then you have plus 9 integral from 0 to pi e to the pi times sine of x dx. That's what you did. And then you said, well, I have 9 of them here and 9 of them there. So when I add 9 plus 9 together, I get 18. So 18 integrals 0 to pi e to the sine of x dx. Okay? So, by the way, there's nothing wrong with that. But the problem is that that is not the problem we're trying to solve, right? We're trying to solve not 18 of those that we have. We're trying to solve 9 of those that we have. So then what's left over here is no good, because this is not what we're trying to solve. We're not trying to solve 18. We're only trying to solve for 9, which is where we started. So let's look at this problem and what you have in purple here in a bit of a different context. So I'm going to recopy what you had in the last 2 lines of the purple. So integral from 0 to pi 9 e to the x times sine of x dx. And then I'm going to add this term that you added over here, just like we did before a second ago. So plus 9 integral from 0 to pi e to the x sine of x dx. And so the context that we need is we need that to look like, we need it to look like this. By the way, what you have here we can fix, and we'll fix that in a second. But if we look at this in a little bit different light, I'm going to change the color here. So integral from 0 to pi 9 e to the x times sine of x dx plus, and then if we move the 9 back in, we have integral from 0 to pi 9 e to the x sine of x dx. So then now we have 2 of those, integral from 0 to pi 9 e to the x sine of x dx. And that, of course, is equal to this whole term that we have here on the right-hand side after we added this part over. So we move that to the right-hand side, and we're left with this stuff over here. So I'm going to copy that down as well. So that's equal to negative 9 e to the x times cosine of x plus 9 e to the x times sine of x. And the issue then, of course, is the fact that we now have this thing on the right, which is similar to what we're trying to solve, but it's not what we're trying to solve. We're trying to solve this. So they're not exactly the same, right? So what do I have to do? I have to divide both sides by 2. So I get the integral from 0 to pi is equal to 9 e to the x sine of x dx is equal to, and then a half times whatever was on the right hand side. So that makes the most opportunity. I have no idea why sometimes I'm deciding to put my x's inside the bracket and why I'm not. I should always put them in. So now when I look at the problem, I have exactly the question I started with on the left, and I have it equal to something that I can evaluate on the right. And by the way, our notation here is a little sloppy, so we should also have, because we have bounds of integration, we should have a bounds of integration on the left as well. It's a little sloppy in each of these other terms, but that's okay. We're among friends here, right? Okay, so now let's look back at this green one and see how we could have fixed that. So we ended up with the 18 times the integral of 0 to pi of 9e, oh, not 9, let me fix that, of e to the x times sine of x dx. That's what we had. And we need that, again, to solve this, we need that to look like this. Okay? So how do we convert that? Well, you could have said, oh, that's the same as 2 times 9, integral from 0 to pi, e to the x times sine of x dx. And then that's the same as 2 times integral 9 on the inside, 0 to pi, e to the x sine of x dx. And then now we're at the same step that we were here, where we can divide both sides by 2. So everything that you did in your problem was correct, except for the fact that this last statement is not true. I have to have a 9 in here, and this part with the 9 in there is equal to whatever's over here on the right hand side. And with that 18 there, then this would not be a true statement. So let me be clear about that. This algebra that's here is correct. But in order to solve the problem that we are being asked to do, we have to convert to make things look with the 9 here. And this with the 9 is what we needed. This algebra is correct, but it doesn't answer the question that we're being asked. Okay, I hope this helps. If you have any questions, let me know. And I'll be happy to help with anything I can.